we have to be very, very quiet. We're hunting rabbits, and there's people in my womb. So we're going to talk about math real quiet today, because they're looking at me like I'm crazy. I didn't tell them I was making a video, so this is exciting. Now they're upset. I like facial expressions. This is awesome. Okay, so today we're going to be talking about 2.3 remainder and factor theorems. Basically all this is just polynomial division. So with our regular long division, if you had like 4 divided by 214,879, right, you would go step by step and you just divide stuff. So you'd say 4 doesn't go into 2. No, it doesn't. But it goes into 21, what, 4 times? I hope so. Because then that makes 16. Oh no, you silly. 5 is 20. And then we subtract that line, yeah? So we'd have 1 and we copy down the rest of this. 1, 4, 8, 7, 9. And then we could put up a 3. I can do math this time. And we'd subtract the 12, so we'd have 2, 8, 7, 9. And then it would go into 28 7 times. So I'd have 28. So 0, 7, 9. And it would go into 7 1 time. So 4, 39. And it would go in 9 times. So 36. And I would be left with a remainder of 3. Yeah, and then this would just be 53,719 and 3/4. Notice with the remainder, I put whatever I have left down over here over what I'm dividing by, and each time I subtracted the next line. Yay! Okay, so there are 2 types of division in general. The first type, which is what we're going to do first, as you can see, is called polynomial division. Is also called long division in your book. So this is how we set it up. Okay, so just like in division, whatever you are dividing by goes on the outside. Whatever you are dividing goes on the inside of your division. And you are just going to take these step by step. When you're trying to figure out what goes on top or what you can multiply this by to get to be able to divide this or subtract whatever you need, ignore the -3. So all I'm going to look at on the outside when I'm trying to decide what to put on top is the first term. Well, to get these to be the same, or as close to the same as possible with our last one that we saw with just regular division, we would have x times 2x to the third, because x times x to the third will give us x to the fourth. 2 times 1 will give us the 2. So now when I multiply this to subtract whatever I need to, 2x cubed is 2x to the fourth, times the -3 is minus 6x to the third. And then I'm going to subtract this line, because that's what we did in the last one, right? We always subtracted the lines. Yeah. So in order to subtract the lines, I'm going to subtract, and you have to subtract the entire line. So really this is going to become -2x to the fourth plus 6x to the third. That will make 0. If it doesn't, then you did something wrong. Go back and check your work. Then you have -x cubed minus 38x squared, and I'm just copying here. Okay, and then you can go back through the process again. So in order to get to the first term down here, you'll have to multiply x by -x squared. So you will get -x cubed. Is that times the -3, so plus 3x squared. So again, subtract this line or just change the signs. That term goes away. Again, if you haven't gotten that to go away, something's wrong. -41x squared plus 103x plus 60. Same process again. To get from x to x squared, I have to multiply an x. -41 from that is -41. So I get -41x squared plus 41 times 3, 82, 123, 23x, and subtract this line. So we get -20x plus 60. Uh-oh. Somebody has to go back to class. I don't want to go back to class. You don't want to go back to class, so go home. Don't do anything. Go yell at the monkeys in your head. They told me you're crazy. change signs, and we have a zero remainder. So what that means is this is our answer. That is what it's divided by. If it ever tells you to put it in factors, don't forget that you can multiply this entire term, put that in a different color, this entire term by x minus 3. All of this multiplied together will give you what you divided out of it. Cool. All right, here's the next one we're going to look at. I'm going to go ahead and do our division, and then we can get going with it. But get it down, try it, see what you can come up with too. All right, here we go. So again, ignore the outside, except for the first term, if you're trying to figure out what's going on top. So get from 2x squared to 4x to the fourth. I need to multiply by 2x squared, and then multiply 2x squared by all of your terms to get the next line. So magically, magic, poof. And we can change the signs, so negative, negative, positive, because you have to subtract that entire line. So then we will end up with, I don't remember how I left it off, but there it is. So since we are left with this, again, I'm going to ignore everything else except for the 2x squared while I'm trying to figure out what I need to multiply to get to the negative 16x cubed. 2x squared needs to be multiplied by negative 8x in order to get to negative 16x cubed. So then I'll have negative 16x cubed minus 8x squared plus 8 times 12, that's sad, 96x. Shouldn't have taken me that long. Change signs because you're subtracting a line. And then that makes 0. You have 18x squared. What is that? Plus 14x minus 84. And then to get from 2x squared to 18x squared, you have to do plus 9. So I have 18x squared plus 9x. I'm bad at math today. Minus 108. I think that's right. If it's not, I'm sorry. I promise I will do better in the future. Negative, negative, positive, change your signs. That goes away. So we're left with 5x plus 24. So notice we have a remainder in this one. So like always, with your remainder, all you're going to do is just say plus your remainder over whatever you are dividing by. So 2x squared plus x minus 12. And there would be your answer. Cool. All right, and the other type of division that I was talking about was called synthetic division. I love synthetic division, but notice on the bottom here, we are dividing by a linear function. With synthetic division, it has to be linear on bottom. It has to be linear denominator. Linear demon. Okay, this is going to look a little weird, but this is a division bar kind of upside down. You need to leave space for 2 lines of numbers. So there will be a line of numbers on the top, there will be a line of numbers on the bottom, and then we'll have some more numbers down here. The number that you're going to put on the outside is always going to be your x plus 2, but is going to be the 0 of it. So x equals negative 2, so I put a negative 2 on the outside. The numbers that go on the inside, I'm going to put them right in the same line as the negative 2. It's just going to be the coefficients or the numbers in front of your terms that you have in your division. So we have 1x to the 6th, we have negative 2x to the 5th, we have 1x to the 4th, negative 1x to the 3rd, 3x squared, negative 1x, plus 24. That is how it is set up. Now, you're going to love this because this goes way faster. 1 plus 0 is 1. When you are inside, you are going to add or subtract, whatever the signs say. To get back to the inside, we're going to multiply. So negative 2 times 1 is negative 2. Negative 2 minus 2 is negative 4. Negative 4 times negative 2 is 8. 1 plus 8 is 9 times negative 2 is negative 18. Negative 19, 38, 41, negative 82, negative 83, ooh, 166, 190. The last number is going to be your remainder. Alright, now we started out with x to the 6th, and we divided an x out of it. If you have x to the 6th and you divide an x, you really just have x to the 5th. So this is going to go right in order. So you'll have like x to the 5th, x to the fourth, x cubed, x squared, x, nothing, and remainder. So then it's just a matter of rewriting this thing out so that your answer will come out as 1x to the fifth minus 4x to the fourth plus 9x cubed minus 19x squared plus 41x minus 83 plus 190 over what you're dividing by, which was x plus 2. And there it would be. A lot faster than long division. Okay, again, we are going to use synthetics to divide. Notice in this one, though, it goes from x to the fourth to x squared. If it skips any terms, we need to make sure that we put in a 0 as a placeholder. Just like if we had division, if we had 2,140,879, we wouldn't just ignore this 0 because it's a 0. We would have to write it there because, I mean, that's a part of your number. So this is a part of your polynomial having the zeros there. So in the synthetic division, I will write 1, 0, negative 13, 0, 36. On the outside, I write my 0 of the bottom. 0 of the denominator is 3. 1 plus 0 is 1. 3, 3, 9, negative 4, negative 12, negative 12, negative 36, and 0. Hey, oh, there's no remainder. So if you have no remainder, that actually means this is a 0 of the function. So like in the last one, negative 2 had a remainder, so that was actually not a 0 of the function. And kind of cool beans, if we had like f of negative 2, that's actually equal to 190. Oh. Anyways, we'll talk about that in a little bit. So here, again, I started off x to the fourth, so it will come out x cubed. So I have 1x cubed plus 3x squared minus 4x minus 12. That would be your answer. Again, just remember, though, that if we multiply this by x minus 3, this would all give us back to the original thing that we started with. All right, in this example, we are going to be factoring. So kind of like the last one, we're just going to use synthetic to divide. Since we have a linear function, we can divide by it. So once we get to this point, hopefully this will be small enough that we can just factor it as is. So here's our synthetic. Right there it is set up. You have negative 3. Don't forget you are setting it to the 0, so you have a 3 on the outside. 1, 2, negative 21, 18. Pull down the 1, you have 1, 3, 5, 15, negative 6, negative 18, 0. So really, if it started out as x cubed, this is x squared. So we can rewrite what we divided out as x squared plus 5x minus 6. And don't forget this is all times x minus 3. Well, that will factor pretty simply. This will be x plus 6 and x minus 1 and x minus 3. And there we go. There it is, factored out completely. Okay, in this example, again, pause the video, read the directions, think about it, think about what it means. But all we are trying to do is determine whether this factor is a factor of that, and if this is also a factor of that. So the easiest way to check this is just going to be using synthetic division. So if I choose this one first, I can say negative 2 on the outside. 1, negative 2, negative 9, 1, 6. Didn't skip any. 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. Bring down the 1, 1, negative 2, negative 4, 8, negative 1, 2, 3, negative 6, 0. So remember, all that we are looking for, if it is a factor, you will have no remainder, which means it is a 0 of the function. So x plus 2 would actually be a factor of it, so we are good to go there. And then if we try the other one, we would have a 1 on the outside, still going to go from the same polynomial. Bring down the 1, 1, 1, negative 1, negative 1, negative 10, negative 10, negative 9, negative 9, negative 3 remainder, so x minus 1 is not one of them. All right, this one's a fun one. I like this one. It's exciting. Yay. So if I set up synthetic, I want the remainder to be 0, so hopefully we'll have it set to 0 at the end. That's what we're going to try to make. I will have negative 2 on the outside, 1, 18, k, and 4. So in doing my regular synthetic, I have 1, negative 2, 16, negative 32. This will be k minus 32, and then if I multiply by negative 2, don't forget to multiply all your terms, so negative 2k plus 64. And then my remainder will be negative 2k plus 68, but I want that to equal 0. So in order to solve for k, I can move over the 68, so negative 2k equals negative 68 divided by negative 2, and k is 34, hopefully. And if you want to, you can double check. Schmebble schmick. Double, I don't know, George Lucas eating apple pies on a Sunday afternoon, and he likes bananas too, is what I've heard. Hold on, 1, 1, negative 2, 16, negative 32, 2, negative 4, 0. Help! Happy day! So k is 34. Yay! Okay, I like these ones. 1, you can plug in 2 into the x's. Yes, you can get the function value. It goes a lot faster with synthetic, just like when I showed you this one. If you're given your x value, whatever your remainder comes out to be, that is what it is at that point. So just doing the same thing, setting up synthetic. Don't forget, this one goes to the fourth. I have no x cubes, so I'll need to write that. I have no x's, so I'll need to write that. So I have a 2 on the outside, 2, 0, 3, 0, 7. Notice this one, it gives me x equals 2, so I don't need to really do any work to find my 0 or anything like that, or whatever that function is that I'm putting on the outside. Whatever that number is on the outside, it's not a function. Crazy kid. So 4, 4, 8, 11, 22, 22, 44, 51. So f of 2 is 51. Hopefully this video has been helpful. I will see you guys sometime, maybe, hopefully. Bye!